My dear friends, so today's session we are going to talk about two new topic in function, and this is going to be the last part of the function series, and after that we'll head back to the next topics in Julia. So today we are going to learn about do block and the function composition in Julia. So this is your first topic, do block. So to learn do block, we first have to remember the what is anonymous function and how anonymous function work, and you can feel free to check out my videos. I'll put the information in the top right corner. You can check out the video where you can know about anonymous function. So this is a code snippet which is actually trying to do there is a list of number 2 3 4 5, and what we want to calculate the square of every even number and cube of every odd number, and then store them in a list again. So what I did, this is a map function provided by Julia. This function can iterate over any list. So here what we did, in the first argument I am passing an anonymous function. This function begins here and ends here. This function, what is doing actually, it is checking for even or odd and then returning square, otherwise it is returning cube, and the second argument is the list of number. So if we see the output in the console, so here you can see with the anonymous function we have this list 4 27 16 125. You can do math better than me. Now we can do the same with a very much clearer syntax, interpretable and recommended by Julia community with do and block. And what it does the same thing, but with more convenient way. Here what you can see, in the same map function we are passing the list, the sum numbers, the list as argument, and then we are starting a do block which is ending over here in line number 32, and we can pass multiple argument with comma and so on. So here we can pass x and it does the same, and we can have the result over here, and let me save the file and let's see the answer. Yep, so both answers are same with very much convenient and clearer syntax. So let me give you another example where do block actually helps us with file. So you all know, at least those who are from a little bit of programming background and hands-on on file handling, so it is a very big trouble to create a it is a very big trouble for the developer who used to create a file pointer and forgot to delete the file pointer, and after some time the application crashes due to the file pointer overflow. So now Julia solves this very efficiently. So what we are doing actually over here, I already have created a file called fp4.txt, and this is the text this file contains fp4, and what I'm doing over here, I'm trying to open the file. So this function will return a file pointer, and I am taking the pointer in this parameter, in this argument with a do block, and then I'm trying to perform my work. And in our case I am just reading the file content in string format, saving it to a variable named text, and then printing it out, and then closing the do block. And what is important about this, it will automatically close the file pointer also, so we don't have to explicitly close the file pointer. And let us have a look what it is doing. So those are the old outputs, and this is the output that we may be interested in here. So this is the text file, and the file contains ap4. So this information has been printed over here. Now we can head back to our next topic, and this is the last topic as well for whole function series. So in this is called function composition and function piping. And to have an idea what is that, we can talk about functional programming, especially in people who are working in JavaScript framework. They know what is functional programming, but in summary, what I can understand that this is a kind of way of writing program where instead of returning a returning a value, we return a function, and then function handle the next operation. And here in Julia also, what we can do, we can club together multiple function one by one like a chain, and one function will perform something, then generate some result, and the same result will pass to the next function, and the next function will perform something, and the same result can be passed to the another function, and so on. And we can do this very efficiently. So to have a brief overview, what we can take an example, like you can see we are trying to add few numbers, then find the square of the answer. And let us have an example of 1 2 3. So we want to add this 3 number first, and then we want to find the square. So to do the same, what we can do, this is the another function in Julia library called reduce. So what it does, it used to iterate through a list, and then after all it will generate it will generate an answer based upon your operation, and after all the single answer will be received by the variable. In the later chapter I can explain reduce, or you can check out the description about the reduce, how reduce work. But you can for now you can say that reduce will help you sum up those 3 numbers. And then there is another function square. So it will actually square the sum, and you have the answer. So let me save it and print it. So after this line we are supposed to have an answer. Okay, this is the line, and the sum is 6 and the answer is 36. Fine. Now we can do the same. So here what is important, we are first performing a sum and then performing a square. So we are trying to call 2 function, and we can do the same with a very clever syntax. This is called function piping, or function composition. This is the function composition operator. And what it is saying that it is saying that first we have to perform summation over these 3 number, and then we have to perform a square on the answer, and then we can find the answer. And see, we can have the same answer, 36. And this is some other information, some important syntax that you have to remember every time. So this is the order of calling. So if you club together, we can club together multiple functions, and this way, but the calling order will be right to left, and the arguments that we are passing will be fed to the first function. And there are a few strict rules that you have to remember. So the first rule will be the function has to return only one value, not tuple, and the functions in the inner part should accept only one argument. Not, I'm not talking about the first function, the rest of the function. So the first function can accept multiple arguments but only return only one value, and the rest of the functions can only accept one argument and return only one value. If you require to return multiple return values, or if you want to return a tuple or name tuple, yes, I already discussed about this in another video. You can check on the link I mentioned on the top right corner. And so you have to accommodate a mechanism called argument destructing, and in this way you can pass multiple argument and you can return multiple argument in this kind of function composition. And let us have a quick look on that. So consider we have a function first, second, third, fourth and last, and the first function is accepting two argument and returning a sum. Second function is returning a tuple. This is kind of returning a tuple, and what is actually doing, it is just returning the multiples of a number up to 4. And then the third function is this is a syntax of argument and destruction mechanism, where we can accept 4 argument directly from the caller side, and obviously the caller has to return or pass a tuple. And what we are doing, some simple mathematical operation, we are adding m plus p and n plus o. You can do the math yourself. And another function ab, it is actually returned 2a plus 3b. And then the last function is accepting only one argument and 2m, and we can do the same with this syntax: last, fourth, third, second, first, and 1 1. So 1 1 will be added to 2, then 2 will pass here, then we are going to have 2 4 6 8, and this will return, this tuple will be returned to the third function from second to third. The third will accept this 4 number as m and o p, and then it will return m plus p and n plus o. So in our case it will be 10 plus 10, surprisingly. And this answer then will pass to the fourth, and fourth will again accept this tuple destructed in a and b, and then it will return 2a plus 3b. So in our case 10 will be passed for a and b both, then the answer will be 2a plus 3b, which means 30 plus 20 equal to 50, and then 50 will be passed to fourth to last as a m, and then m will return to m, which means 50 into 2, which is 100, and the answer will be stored, and we can see the answer. So this is 100. So there are enormous possibility, and as well as maybe you can optimize this also. So here if we optimize this, instead of writing this, we have another better syntax 3. So this also does the same. See, 36 6 36, same. So this is all about function chaining or function composition, piping, and do block. And that's all for today, and this is the very end of the function series, and this is the function part 4. You can check out all the other parts in the description, and thank you for watching. Bye bye.